Hey guys, today we'll be talking about database connectivity and different web technologies available on the market. We're gonna start from the older technologies that are still on the market, and then we will progress to a newer one. So, today, just like I said, we will talk about different database connectivities, the reason why database connectivity is important for you guys to understand and know, besides the fact that it's going to be part of your team project. We will look at different older and current database connectivities, including ODBC. OLE and ADO.NET, and we'll also talk about JDBC, which is a special case for Java. We will understand how middleware works, what is middleware, and what is the reason why middleware is very important as part of database connectivity. We'll look into different types of web application servers, and at the end we'll talk a little bit about XML and different options for cloud computing and advantages and disadvantages that are related to cloud computing. So we're going to start from very basics. So what is database connectivity? Database and connectivity is refers to a process of connecting web application or programs to an actual database. Now we know how to create database. We know different database objects. We know how to put data to the database, and now we are going to learn how to actually use the database that we created and SQL queries that we created with the potential applications that will be using those databases. So when it comes to database connections to an applications, very important role plays database middleware. Middleware is a set of applications or routines that provide a connection between applications that is using the database and the database itself. So it uh, um, it functions like an interface, getting connections from both database and application and making sure that the data flows from the database to the application. So when it comes to database access, we have three different common interfaces on how to get data from the database, and those include ODBC or EDB and ADO.NET. There's also JDBC, but JDBC is specific for Java, and it functions almost like ODBC, but for Java applications. And here you can see a diagram of the middleware. So similar to how a middleware can exist on the database server, right here you can see that middleware can sit as a separate set of routines in between user and the database, as well as on the user side. So why database connectivity is important? Well, why it's important? Well, first of all, let's start from the reason why it's important for you guys to learn database connectivity. Well, a lot of you will be dealing with managing processes and procedures for larger organizations in the future, and a lot of you will be dealing with managing software teams, software engineers teams who develop applications that work with the database. And as a person who works with a software team, it's very important to have some technical knowledge. And one of the very important technical knowledge lies in the understanding on how database connects to user applications. So you will today you will be able to understand how this process works and how data flows from application to the database. So again, for you as future managers or future maybe high-level engineers, it's very important to know how databases are actually used in industry. So in addition to that, database connectivity supports the most important process, data access and data retrieval from the database to the application. Because again, the reason why we develop databases, we develop them to support some processes and future applications or programs that will be retrieving data from the database. As you remember, in our first class, we talked about this girl Susan. We talked about her day. We started from the fact that she goes to the grocery store, and again, like there is a database behind the grocery store cash register. Then she goes and orders prescription from the pharmacy, and as we know that there is also a database that supports those transactions and so forth. So behind every application, behind every app on your phones, behind every process that deals with retrieving the data and displaying it on the screen, there's a database, and obviously that needs to be connected to the application, and that is to support data access and retrieval from the database to the user application. It's also important to support data persistence. So all the applications, majority of the applications store data. And why do we store data? The reason why we store the data is for future use, analysis, and utilization in the process. So data persistence is another reason why database connectivity is important. So also real-time updates, what does it mean? When it comes to real-time updates, many applications require you to know the state of the data on the current point of time. For example, we talked about bank transactions. So if you and your partner or your significant other or your parent have the same checking account, and say, for example, you have $100 on this checking account. Well, it's an unreasonable number, but still. And say you go to the bank with your card, and you try to withdraw money. For example, you're trying to withdraw $50 from this account. Well, at this time, it's very important that account has the latest updates, so we would know at what point of time the account balance was $100. And say, for example, we're trying to withdraw $50. So as you process your transaction, your significant other on the other terminal is trying to withdraw $60. So if your real-time updates didn't make to update the balance, your account might go very quickly into the overdraft. So again, what's happened in this specific scenario? Database issue a lock up until your transaction is completed, and then process another transaction. So to make sure that two transactions don't hit the same account at the same time, and your balance is up to date. So that goes to real-time updates. It's also important for data integrity, security, and scalability. And we talked about scalability in the past. So scalability is an ability to support data grow in the system, which is vertical scalability, or expand types of data we store in the database. That refers to horizontal scalability. So We talked about why it's important to connect to the database and why database connectivity is important for application development. So we're going to start talking about different types of connectivity. And the first one that comes here will be native SQL connectivity. So when we talk about native SQL connectivity, it means a direct access to the database through a specific code or specific program. So, for example, my SQLite connects connection to a SQLite database using Python application. So we use native connection developed specifically for this database, and it's only going to support connection to this database. You can't connect any other data sources. You can't connect any other types of the databases. Another example is SQL, MySQL connector for MySQL database. So it can be only used for MySQL database. It can't be used for any other type of databases. So when it comes to native connectivity or native code to connect to the database, the advantages for that are it's fast, convenient, efficient. It provides quick access to the database, quick data retrieval, and it has its own source code or application programming interface called API to connect the database. We're going to talk about API later on, but for now, just think about certain types of procedures that are very specific for a certain database. It's very easy and efficient to use. Well, disadvantages on the other side deals with the fact that it's only limited to a certain type of the database. So in this case, if you're talking about MySQL database or SQLite database, it only allows you to connect one type of the database. So there is a connection to SQL like in Python application or MySQL connector used for MySQL database. So it's really, it's not expandable to any other types of data sources. So every connection to a different type of data source, every native connectivity requires its own type of connection in the code. So where do we use that? We use that for simple one one data source applications that do not need to retrieve data from multiple sources. So, for example, it can be a simple app for a certain doctor's office that is very specific, excuse me, for this doctor's office. It can be some learning apps that we are going to create in this class. It can be anything that is simple enough that it's require only one data source. A good example would be maybe simple app on your phone that say tracks your daily activities. So or notes applications which tracks your notes for a day. So very simple, very specific use application. Okay, so that's native SQL connectivity. Well, there is also open database connectivity called ODBC. My honest open opinion about ODBC is I was under impression that it's not gonna last long. So this technology been used when I was in college. This technology was used when I started working in 2003, 2001. It's somewhat old technology, but I can say confidently that it's still very strong on the market and it's probably going to stay alive for much longer. So that's why we're going to talk a little bit about it. So ODBC is a specific Microsoft technology. It's a Microsoft implementation that allows Microsoft application to connect to different data sources. Um, ODBC allows you to connect to any data source you like. You can connect to SQL Server database, you can connect to the Access database, you can connect to Excel spreadsheet, you can connect to a text file or CSV file, whatever you want. So it is the concept and the technology is database agnostic. So it can be used on a wide variety of different relational databases, including SQL Server or even Oracle, MySQL, Postgres, anything you want to connect, including even non-database sources. Important to understand that it is driver-based technology. So it requires a specific driver for you to be able to connect to the database. What is a driver? I had this question with one of the classes I was teaching. So driver is a specific set of programs or routines, very simple, that allows your hardware on your computer to work with your software. So, for example, you're connecting your mouse to your computer. So, the moment you plugged in this USB into your computer, the thing, I don't know if you guys see it, like the moment you plug in your connector to the computer, that is going to install a very simple driver. As you can hear the noise now, so that's a computer installing driver. So driver is a program that allows hardware to talk to software. So ODBC is driver based, and each database system that we're about to connect to requires its own database driver. So, for example, if your application is connecting to both database to two databases, one Microsoft SQL Server and another Oracle database, you will need driver for both. So you will need your application to work with those little programs called drivers for both databases. That's all I got for about ODBC, but overall, I was thinking at some point, what is the easiest way to explain the actual connectivity, database connectivity, and for example, specifically ODBC. So think it is a translator. It is a translator application that helps us to read the input from the database and translate it to the user. So think of this example. Say you're in a foreign country and you're trying to, and say, for example, you're in France and you don't speak French, and say you don't have a phone with you and you're trying to get a direction from one place to another. For example, you're in Montmartre, and you're trying to get from there to a city center, to Eiffel Tower. And you don't have any technology with you and you're trying to get directions. So, well, um, think about a translator that is standing and translating your words into a person who you're about to talk, and this person is giving you answers through a person who is translating. So in this case, the person who is a translator, who knows both languages, English and French, is going to be ODBC connector. And in this case, you're an application and your data source is a person who is a native person who knows the area and who is able to give you direction. So again, think of database connectivity as a translator middle layer that sits between application and the user. This is an example of ODBC connection string. So connection string consists of multiple elements. It is obviously a data source, so you need to specify the name of the database that you're about to connect. So you specify it here. Then comes, oops, then comes, oh, it's happened. Sorry, guys. Then comes user ID and password. So you obviously need to have username and password to connect to the database because otherwise you can't access the data source. And majority of the databases are user ID password protected, unlike our SQLite database that we use for learning purposes. But majority of the real world applications, actually all of them, are password protected. You also need to know the port. So that is a network port that is used for a connection. For those of you who took one MS 180 class, we talked about different ports. So port, the easiest way to explain a port is just a part of the computer hardware that is dedicated for connecting to a specific other application. So, for example, HTTPS application sits on port 8080. SQL Server sits on port 1533, and so forth. So we need to know ports, and then there is a set of additional options that are important but not so important for certain databases. So that they include timeout, encryption type, and so forth. Timeout is at what point of connection if there is no data flow, we're about to time out. So that is for engineers to set. But again, it's all about business needs. So it can be 30 seconds, it can be 10 minutes. It all depends on what is the specific expectations. For example, if your application runs on very slow network, your timeout is going to be much slower, much higher. So versus when your application runs on fast network, you expect the data to start flowing right away. So that's all I have about ODBC. There's a little diagram that explains how ODBC works. So we start from the client application, we send a request to ODBC driver, then driver sends a request to the manager, manager talks on driver on the database side, and then through the network, we send a request to the database. And exactly the same way, data flows back to the client. All right, so that was all about ODBC. Let's talk about DAO. DAO stands for Data Access or Object. So uh, it acts like a helper between application and the database. So this it's also a set of programs or scripts or small routines that develops an ability to access the database via pre-created code. So it provides specific methods on how to add, update, retrieve data from the specific data object. So, for example, when we talk about, say, for example, your bank application, once you secure a connection between your application and your bank account, it creates a data access object that allows you to specifically access your different accounts. It has all the methods to function with your account. So, for example, you're trying to pay some bills, there is a method for that, programming method for that. For example, you're trying to transfer some money between your accounts, there is a method for that, and so forth. So it is an object that has different connections to the database. It's a programming object. It's a program. So advantages of using that, or it's simple. It also separates specific database code from the application code. So it makes your access to the application much easier. Um, it also helps data structure, code structure. So it allows you to hold all your code related to the database in the one place. And here I have an example. Think of data access object as a data assistant that manages all behind the scene processes to maintain connection to the database, and at the same time keep your code clean and organized. Again, that is a programming object. So that is a programming concept, like software engineering concept. Um, there's also a remote data object. It behaves very similar to the data to the data access object, but it's just on the remote server. So what is the only difference with that is the object is created on the database side. So you use this object exactly the same way as you use data access object. It's just resides on the server side, on the database side. And again, like example is very similar. So you're retrieving data from the bank. Program creates a remote data object, and this remote data object is used um, to work with the database and to retrieve you data from the database, to update data from the in the database, and so forth. And same advantages: allows to keep code very clean, allows to separate coding concept from the database concept, so separation of concerns, programming structure, and so forth. So that's RDO. Um, there is also OLEDB. OLEDB is also somewhat older concept. So OLEDB is a technology that allows us to interact with the different types of data sources. So similar to ODBC and RDO, it is a translator, so it gets the data from the database and it gives it to the client application. So it also allows applications access and manage data without need to know how the database is structured. So you just access the data using a specific connection, but you don't need to know what kind of tables database has. So it's already accessible for you through OLEDB. So the difference between OLEDB and ODBC, so ODBC is it works with relational databases. OLEDB supports all forms of the data stores, relational, hierarchical, and so forth. So OLEDB also provides more advanced interfaces. So say, for example, if you need to do some manipulation with the data in the data objects, you use OLEDB. And OLEDB is still part of the latest SQL Server install. So again, that is a Microsoft documentation, so it's still available and it's still used. All right, and that is a diagram on how OLEDB architecture looks like. So on the top we have client applications, different type of applications, can be Access, Excel, whatever you need to use as an application. So you can have client You can have client code, you can have a software that sits on top of, excuse me, those client applications. So then you have already the providers, service providers, and that talks to data providers. And on the bottom, you have your data sources. Well, you can see that some of them are databases, some of them, well, there's different databases. There's also email. And again, like email is a fantastic data source when you need to read data from the email server. So you have database that connects through DBC, and you also have database that connects through .NET. We're going to talk a little more later about ADO.NET. All right, and here's our ADO.NET. ADO.NET, well, first of all, what is .NET? .NET is a framework developed for Microsoft for engineers to create different programs or applications. So along with .NET comes Visual Studio, that is an environment where you can develop your code. And obviously, specifically for .NET, there is a different database connectivity called ADO.NET. So ADO.NET is a technology that is used to connect programs to the data stores or databases. So it also acts like a bridge, very similar to ODBC and OLEDB. So, but specifically for .NET applications, and again, it allows us to retrieve data from the databases, update data in the databases in structured way. So again, ADO.NET, it is a database connectivity specifically developed for .NET application, and .NET is a framework used by engineers. Guys, also all those terms that we are covering in this lecture, ODBC, OLEDB, DAO, RDO, ADO.NET, those are very important terms for future business technology majors, because when it comes to technology, you will be part of teams who will be developing solutions. And when you develop solutions, you need to know what kind of data sources you will be using. You will be analyzing data sources. And obviously, you will have an application that will use data sources. And between those applications will sit database connectivity. So again, like all this terminology is very important for you guys to understand as a future business major who will be working with technical teams and hopefully managing technical teams. All right, so here is a diagram for ADO.NET. It's very similar to OLEDB, but in this case, you can see that ADO.NET is a large set of frameworks that have data adapters that allows us to read data from the databases, and usually it's one adapter per table. Well, there's also data tables, and those are this is a code representation of data objects for the applications to communicate to. And on the bottom, you can see that we connect to the database using OLEDB driver. So there's also Java database connectivity called JDBC. JDBC is very similar to ODBC, but it serves specifically Java applications. There's a bunch of advantages that are very similar to ODBC advantages, but again, Java is a programming language, and Java applications communicate to the databases using JDBC. So JDBC is native connectivity for Java applications. So there is a native driver there. So it allows Java applications to connect to database using JDBC middleware. And there's we can also use ODBC driver for JDBC as a special case because again, ODBC driver is a universal driver. Diagram for JDBC, again, very similar to the previous two. We have a Java application, JDBC API, application programmer interface, which we're going to talk in a few minutes about. And then there is a driver manager. And on the bottom, we have different different databases, data sources. That some of them have ODBC driver that allows us to connect to the JDBC driver manager, and some of them have database middleware, set of applications that sits between the database and our actual application, in this case, between JDBC driver and the database. So this everything before this slide was part of the book. Starting from this slide, I deviated from the book a little bit because I feel like you guys need to know how the real world works with the database. And I wanted to show you how engineers write database code now. So majority of the application development teams use Object Relational Mapper, or ORM. So ORM is a framework that allows engineers to work with a database just like they work with any other piece of code. So it creates a bridge between your code and the database. It also provides you certain level of abstraction of data objects so that you can use those data objects as an object in the code. I'm going to show you a diagram in a minute, but there's multiple examples of ORM. So there is an NHibernate specifically developed for Java, Entity Framework for Microsoft, Dapr for .NET. Dapr is an open source. My team is using Dapr. Dapr is a very interesting technology. Again, like it's open source, free. Anyone can download it and play with it. And SQL Alchemy for Python. Again, besides all those technologies that we talked about, ODBC, JDBC, and anything else, there is ORM, and majority of the engineers use ORM to connect to the database, to retrieve data from the database. So that's how it looks. Say, for example, on the left, you have a table. You have a table that sits on the database side, and this table has 4 columns: ID, first name, last name, and the phone. And once you generate, and the code on the right is generated using ORM. So once you generate the code, you access the person database as a set of as data sets, and you use them as objects. So for example, if you can see Python objects on the right, you can see that person has first name John, last name Connor, and phone number, so forth. So again, ORM allows us to represent data table as set of objects for future use. So here's an example. You don't need to understand in details what is it, but here's an example how the code looks with ORM on the left and without ORM on the right. So as you can see, it's much easier and much more clear on how to use the code, how to write the code, and it allows you to eliminate all this convoluted stuff like database connection, open connection, close connection, set driver, and so forth. You have at your fingertips, you already have, say in this case, album object available for you to work. So advantages, simplify of using ORM, simplify database access, Again, easy, clear to understand for engineers, simplicity when it comes to writing queries. Along with that comes productivity, so our engineers can write more code. Portability, we did talk about portability a lot, and it's very important to be able to use your codes that you say, for example, use for Oracle database to port it and use it for SQL Server database that has the same structure. Um, Reduce SQL injection risk. So, what is SQL injection? SQL injection is cyber attack. That's when your potential attackers use pure SQL code in the text field and send it through to the database. So, again, since we don't, since using ORM will eliminate using the actual SQL code, we reduced a lot the risk of SQL injection attacks. Well, there's a bunch of disadvantages too. So comes with performance overhead, takes time to set up and configure it. Um, Engineers need to spend time learning those ORMs. It's not very easy to write complex queries that requires you to connect two or three tables. Sometimes it is an overhead for a very simple operations. Again, like if you're talking a simple app that manages your note on your phone, so ORM is probably going to be an overkill. And it's also vendor specific. Again, if you once you pick ORM and you start working with the ORM, this is something that you will be using up until you redesign your application to use something else. All right. So, we talked about database connectivity in general. Let's talk about database internet connectivity. So when it comes to internet connectivity, it's the same database connectivity, but over the web. So the only difference, your client and your server can sit on the different sides of the country or the different side of the world. And that would be the same database connection, but just over the network. So you can see that you have a web client on one side, web client on another side, and the web server on the other side, and the database sits behind the web server. So, um, also, when it comes to the database connectivity, it's very important to mention database middleware. So, and this middleware is the actual web server that takes traffic from multiple web clients and sends this traffic down to the database. So, web to the database middleware can be server-side extensions, can be server-side programs that help to send data from the database to the server. And again, web server configuration can be very different depending on the need and the goals of a specific application. So it might need to install different programs. It might need to have a traffic router or stuff like this. Again, it all depends on the business need. Here's an example. Here's a diagram of a web to database middleware. So you can see client on the left that sends HTTP request to the web server. A web server has a set of routines, including different script page that sends data, sends request back to the web to database middleware that in turn sends it to the database via JDBC or ADO.NET or any other driver that is used. And we get back the same data and we send it back to the client computer. All right. So, That's about sending data from sending a request from the client to the server and getting data back. So when it comes to the web server interfaces, there is two important interfaces that we deal with here. That is CGI, Command Gateway Interface. It is a program or a set of programs or set of routines that allows us to send an information to the actual web server. So web server receives the data from the client through CGI. And then there's application programming interface that allows for a communication between web server and the database. So again, CGI helps client to come inside the server, and after client gets their data inside the server, API sends data from the client from the server to the actual database. So API is a very common wide use technology nowadays. So different APIs are developed to allow web applications to talk to clients. I'm going to show you a very interesting example in just a minute. I found it online and I was very impressed on how those two somewhat newer, well, first, maybe it's not so new. Not so new product developed their APIs. So the first example is Tinder API. So, well, as you guys know, Tinder is an application where you can meet people online. Very interesting story behind it was developed. Tinder was developed by two friends who went to hackathon in LA, and the applications that they developed in a hackathon in LA was a prototype for the future Tinder application. So Tinder, again, like it was a very fast growing application. There was like closer to 45 million downloads of that. So obviously, when application became very popular, there were a lot of people who wanted to get data from the database, who wanted to interact with the actual application directly. To, for example, to put some commercial up there, to allow other data inputs and so forth. So every business or every potential person or potential company who wanted to interact with the Tinder required API. And on the left, you can see how API for Tinder looked in the very beginning. So all those circles were specific API developed, specific code developed for each of those clients who wanted to interact with Tinder database. So as you can see, it was very disorganized, very chaotic. Well, and then came two engineers who developed Tinder API gateway called Tag. This was very structured application programming interface that allowed all the client connect to Tinder data without going through the loops, as you can see them here. So the diagram on the right is a structured new way of providing services for potential companies or businesses who wanted to integrate with the Tinder application and the database on a server level, not as client, but on the server level. Another example of API is Uber. So while Tinder took an approach of developing API as they go, Uber developed their API at the same time as they developed applications. So, for example, they had different layers. So they had an edge layer where clients can interact with that. Then there was a presentation layer when certain clients come to the lower level. And teams on the bottom represent different types of businesses that Uber has. So, for example, Uber Travel, Uber Eats, well, now Uber Kids. So, all of those represented by teams. And again, as Uber develops their applications, they develop their API along with the app, which allowed them for a structured, convenient integration of any commercial or and providing their data through the application without client access. Again, two approaches, none of them are necessarily good or bad. It's just a way to develop application program and interface for a future or for the current application. Again, like when it comes to Tinder, it was very chaotic development in the beginning. They didn't know what kind of data they need to provide. So they started from very unstructured process. But again, then they were able to make it, to organize it and make it structured using tag. And with Uber, they took a different approach. They started from structured application and they developed API in the beginning. So to start with. All right. So when it comes to web application development, it's very important to understand web application servers. Web application server is a middleware application that sits between a client and a database. So web application servers can allow you to connect your database to a query, allows you to write multiple queries for the database. It also allows to present data in the web page in a different formats. So it allows you to create dynamic pages and so forth. So it also, when it comes to web application servers, the important things they do for us and important things this code does for us, they allow us to enforce referential integrity. If you guys remember what referential integrity is, it is an ability to maintain connection between foreign key and primary key via foreign key primary key constraint. So I'm going to show you a very simple example of web application that uses SQLite, Flask, and Python. So this is, I wrote this application. Please don't judge. It looks super ugly, but it does the job. So you can take my code and make it pretty. You can make it look good. But again, like, I mean, I'm just an engineer who can do prototypes. I can't do a very good looking UIs. All right, so we will be using Python. Python is a high-level programming language. We, as some of you already took Python classes, we will be using PIP, which is a dependency manager for Python. It's a programming concept that allows to use objects in Python. We will be using Flask, which is a very lightweight framework for Python to build web applications. It allows Python to communicate to different types of web requests. And for the ability to for the data connection or for the data retrieval, we will be using cursors. Cursors are temporary tables that they are stored in memory to hold the data that we process for a specific table. So when it comes to cursors, we first need to establish connection. And as you can see here, we connect to Chinook database, and then we set a connection for the cursor, and then we execute the query. And at the end, we need to close this connection. So there is a very basic diagram of this application. So Python use SQL to sends SQL to the database sends back data, and then we display it in the web application. I'm going to get out of presentation for a second and show you how my application is structured. All this code is posted in the module. So it's posted in the web application module. It's also posted in your team project module. So the entire document that describes you how I did it and what I did is there. So I'm going to show you really quick. It's very simple application. It just have 3 files. So how do I get there? Network users, maybe. Just give me a second. Okay, users. All right, so it's going to be under my user ID, and it's going to be a project one. I'm going to show you first the structure of this project, and then I'm gonna show you how it runs. So as you can see, I have a Chinook database. Here is just a copy of the database that we used in class. I have app.py. That is a Python application code. So I'm gonna open it with Notepad, just show you what's there. So we start from importing Flask. We also import SQLite 3. That is a SQLite engine. And then we call app. And the next set of code, without getting into a lot of details, those are routes. And further down, we have a selection. So I have 2 queries here, just simple queries. So I have a query for albums table. And again, that would be an albums menu. And the query will be select albums title from albums. And then there will be another selection genres. And those will be just parts of the drop down that I use on my web page. And then for the rest, it's going to be invalid selection, but I don't even have this invalid selection there. So then further down, I have a connection and the cursor that I showed you before. I open connection, get all the data to the cursor, and then further down, I display result.html. This entire code is posted for you guys to play with. So you can use this code, you can use anything else for your team project. But again, just for this lecture, you might want to play with this code. And that's it. So that's the end of this application. I also have 2 templates. One to display my initial page, index.html. So let me show you the code. The code is very simple. So it's Chinook data, and then I have a drop down here, albums and genres, and then I have a submit button. So that's my initial code. That's my initial index.html page. Then I also have a result HTML page. So result, sorry, I should have just shown you how it looks. So, and then result has also super simple code. So again, depending on what the query executes, it's gonna put the result of the albums or genres in the table here. So in order to do that, in order to do this type of application, you guys need to have Python installed, you need to have pip installed and Flask, and there is detailed instructions on how to install it posted in the team project. But the way you run it, you need to run it through the command line. It's a little more technical, but again, like, I mean, it's super easy. So I am in the same folder as you can see here, but I think I need to go one folder down. I need to go to the project. See if I need to go to project 1, and I'm in project 1. And the way I run this program, I'm going to run the Python program. So the Python program that sits here is going to be called app.py. So the way I run Python program is I type Python, Python, and then app.py. It's Python. I can spell. There you go. All right. So it's running now. I need to open my web page. So let's go. And since I'm running it on my local host, I'm going to type localhost and 500. And here is my application. So here I have a connection for albums. I can execute it for albums and click submit, and I'm gonna see everything. I'm gonna see the ID and name for all the albums, or I can go back and select genres and click submit, and I'm gonna see genres. Super simple. Again, play with my code, and you will be able to get somewhat similar results here. So that is the way to create web application to retrieve data from the database. All right, so let's go back to our presentation, and that is what I just show you guys. And when it comes to web technologies, it's very majority of the web technologies use XML, extensive markup language, to send data between different data elements. So they to send data from client to server, to communicate between database and a client, to facilitate an exchange of those documents, of those data sets between multiple clients. So XML is very common data format. So when it comes to XML, there is two types of document. It's DTD that specifies, that describes the schema, and then it's an actual and it's actual XML document. So here you can see a DTD example that explains you what exact data will be stored in a specific XML document. And on the right, you can see the actual data stored in the document. So, for example, here you have a book that has title, author, genre, and price, and then you have then element title, author, genre, and price, and then when it comes to the right, you can see that, for example, for book 1, you have author 1 and so forth, and that's one instance of the book, and then down here it's book 2, another instance of the book, and so forth. So again, XML document is a format that is used to send data from one to send data between client and the server. And DTD is specifies a format of the specific XML. Example of XML applications, so used everywhere, business to business, data exchange, web page development, everywhere. XML is very widely used format. So again, like used for multiple applications, and it's along with JSON, which we are not going to cover during this lecture, is the most popular format for data exchanges. And that's about it for database connectivity, different technologies and different formats we use to get data from the databases. And now I have a couple of slides about cloud computing. So cloud computing, it's a modern way to to develop and host applications. It allows businesses to minimize the infrastructure that they need to have in-house to store their information. So example here is a system that uses cloud for the entire development, so they can, as you can see, that everything hosted for in the cloud, and the only thing that is not in the cloud is email and storage that is stored outside of the cloud. Again, very commonly used concept to host the data and even use application development. And when it comes to cloud computing services, there is many different implementation types. So it can be public cloud. This type of cloud allows you to store information for any public use. So, for example, I personally host my website in the public, in AWS public cloud. I have my own instance. There is a private cloud. Private cloud are cloud develops for specific organizations. Um, there is a community cloud that builds for different groups. And there's also a government cloud. Government cloud is used by primarily Department of Defense. So there is different impact layer here, 2 to 5. When it comes to 2, it's for official use only, up to IL5 for top secret information. And cloud providers, the most common today are Azure and AWS. So, characteristics of the cloud services. So they are accessed via internet. They use the same shared infrastructure for everyone. So it's kind of shared garden environment. Easy to start. So for example, from my web page, I pay like roughly $10 a month with about 1,000 to 2,000 users daily, which I think is pretty good. So dynamic provisioning means that the cloud is going to add or remove resources depending on your use. And there's various managed operations that you can pay for when it comes to cloud services. Um, Types of the services, three main types are SaaS, PaaS, and IaaS. SaaS allows us to use cloud service to um, offer applications to run in the specific cloud. So it's a software as a cloud. So for example, majority of the software that you guys use nowadays are software as a service. So for example, Intuit to make taxes, anything that you use software base right now is almost everything is SaaS. PaaS, it's platform as a service. We use platform as a service for my company. It's a model which allows you to allow and deploy applications into the cloud infrastructure, so including the database. And the last one is actually not very popular now, but it's gaining popularity, is infrastructure as a service, which allows providers to use to increase or decrease the resources as needed. So you can use your own infrastructure as a service. So for example, if today you need more memory, you can dynamically add more memory to servers. You can create additional services needed. So it's infrastructure as a service. So this is a typical diagram on how cloud works. So you have your client machines, you have all the devices that connect through the internet to a different cloud providers. And there is a set of services available for software as a service, platform as a service, and infrastructure as a service. So you can look at that in details. We can pause here and see what's there, what's available. So when it comes to cloud services, there is various advantages of using cloud services. Just like we talked earlier, it's really easy and cheap to start. You can they're very scalable, so you can increase, decrease dynamically. It supports mobile devices. It allows for very quick provisioning. It's fast and reliable. So for example, for my website, in the 6 years I've been hosting it, I had actually not six, 5 years I've been hosting it. I had only a few emails stating that the website is down. There is also various disadvantages. Well, it's a multiple hidden cost, difficult data migration. Well, some organizations are not comfortable going to the cloud because, again, like I mean, some organizations prefer to store data in their own devices. Sometimes it's not easy to integrate with existing systems, so all of those are potential disadvantages or real disadvantages of cloud services. But cloud services is a very popular concept and model used nowadays. And for me personally, once I moved to AWS, I moved my personal website to AWS, I was able to cut the cost compared to my previous data previous hosting provider or almost 4 times. So I was paying closer to $600 before. Now I'm rarely over 150 a year. So that's a lecture for database connectivity. Again, if you guys have any questions, please send them my way. And that's all I have for you for today.